What RCM is? RCM is an acronym of Reliability-Centered Maintenance. It's a methodology developed in 1978 by two authors, Nolan and Heap, trying to develop a methodology to analyze the maintenance that is done in aircraft. The result of the analysis of Nolan and Heap was so powerful, so good, that was possible to implement this methodology from the aircraft world to the industrial world. RCM is then a methodology to analyze one installation, the equipment, the subsystem, the system, and the areas that compose an installation to determine which is the best maintenance plan that we can develop in this installation. The maintenance plan then is focused in the potential failure that we can have in the installation, and the maintenance plan tries to eliminate the cause of the failure or reduce the impact of this failure in the result of the installation. The problem with RCM appears because it's a complex methodology. And this complex methodology to develop in a full way involves several resources. In the aircraft world, this is not a problem because the same model, the same aircraft is repeated once and once and once, probably in thousands of aircraft of the same model. And every aircraft costs a lot of money. Then we have money, we have enough resources to contract a full team to analyze every potential failure of a plane. Many resources and many equipment of the same model. But what happened in the industrial installation? The situation is opposite. Every installation is a unique installation, is unique in the world. All the resources, all the money that we spend analyzing one installation is for only one. On the other side, we have not the same resources because the money that we can spend in every analysis is limited, very limited. Then, if we want to develop this RCM analysis of the installation in order to obtain a maintenance plan, it is necessary to simplify the process. This simplification doesn't mean that we need to apply less rigor in the analysis, or we can simplify the methodology. There is a norm, the norm SAE GA 1011, and in this norm is written what is necessary to fulfill to call one methodology a RCM methodology. Remember the principles of RCM. Every item that we are going to analyze, an item could be equipment, a subsystem, a system, an area, or the whole installation. It is necessary to determine the function, the functional function of this installation. And the functional function are a lot of functions, normally between 40, 100, even more. And these functions are divided in two groups. One is the main function, and the second one is the secondary function. Once we have determined this function, it is necessary to determine the failure. Failure means that the function is not fulfilled. And it is possible to have a complete failure or a partial failure. But remember this order: function imply failure. And failure can be provoked by several causes. Every one of these causes that provoke the failure are called failure modes. Failure modes is the same than cause. The sequence, function, failure mode it is necessary to analyze the consequence of the failure. Means the consequence from the point of view of the safety, from the point of view of the environment, from the point of view of the protection, the maintenance cost, etc. And even it is necessary to analyze the probability of the event, the probability to have this failure mode or the failure. Analyzing that, analyzing the probability, the detectability and the severity of the failure, we can determine which are the appropriate preventive measure or appropriate provisional measure to reduce the impact of the failure. When we analyze every potential failure of one item and every potential failure of one installation, we see that the resources that we need for this analysis are very high. And then it is necessary to do some simplification of the problem. One simplification is understand that it's not possible to have a deep analysis of the every item that compose the installation, and we reduce the universe of the analyzed item to a small group of items. And this small group of items that compose the whole installation are called critical equipment. First simplification is then reduce the analysis to the critical equipment. But the second simplification is understand that the critical equipment does not exist. What exists is critical failure. Then to determine which one of these failures are critical and which failures are not critical, it is necessary to determine all the failures that we can have in the installation, and then analyze and understand which one of them are critical and which one of them are not critical. But this second way to analyze means that we need to analyze every one of the equipment that compose the installation, and this is not a simplification. Which is the simplification? The simplification can by other way. It's not necessary to simplify the method because it is necessary to fulfill the SAE-GA norm. The simplification arrives understanding that someone in the world has analyzed the same equipment or similar equipment that we are analyzing, that we can obtain the result of this analysis, the analysis done by other, the analysis done by experts in this equipment, and recover this information to implement the information developed by others in our analysis. Of course, it's easier to correct the analysis of other, to analyze the analysis of other, than do the analysis by ourselves from the beginning. Then the second simplification is recover information developed by others, analyze this information and implement or not, or modifying or erase or create new failure modes or new failure, but starting in a different point, not starting at zero, starting from the work done by others. Then it is necessary to have databases of analysis done by others and implement the result of this analysis in our analysis. This is the second simplification. Remember, two simplifications. One of them, analyze only critical equipment. We don't know exactly what means critical equipment, but we analyze a small part of the installation, probably 1% or less of our installation, and focusing all the analysis in this 1%. And the second simplification is do the analysis, the whole installation, but recovering information, recovering analysis done by others. Which one is better? It is better to simplify the problem focusing in critical equipment, or is better simplifying the problem recovering information developed by others? Of course, in terms of the efficiency, it is the best solution is recover information done by others, because if we don't recover the information done by others, we analyze only 1%, we identify only 1% of the problems of the installation. What happened with the 99% of the equipment that we have in the installation? We focus only in critical equipment, we forgot the rest. But the majority of the problems are in the rest, not in the critical equipment that we are trying to analyze. Then, you believe in this methodology, RCM, you believe that it is possible to determine all the potential failure of the installation. Please check all your equipment, but use database developed by others. For example, the database developed by Renovatec that is available in the software RCM Helper.